All right, we are wrapping up this course. We've covered a lot of information and I hope you've enjoyed it. We're going to do a quick review over some of the items that we covered throughout this course. We kicked things off talking about VLANs, or virtual local area networks. We got into how we segment the traffic and break it apart into different segments, and how we can use switches and VLANs in order to do that segmentation so we don't have to have lots of switches for every network that we have. We talked about different VLANs that we could possibly have, like the default DVLAN, the data VLAN, the voice VLAN, management VLAN, and native VLAN. And we also talked about VLAN Trunking protocol that allows us to be able to distribute VLANs across our whole switching infrastructure. Then we took those concepts and we applied it to an actual network that we were working with, a mock network. Once we did that, then we moved into VLAN Trunking. We saw how we could use a single link but still have a lot of different VLANs across that link, sending traffic across it. We got into how 802.1q adds a tag to the frame, so that way when it leaves the switch, that VLAN is now tagged on that frame, and when it gets to the other switch, now that other switch knows what VLAN it's a part of. We also talked about how to automatically set up trunking with things like dynamic trunking protocol. From there, we applied these settings then to our network. We set up trunking and did some VLAN troubleshooting on it. Then we needed to route between these VLANs. So we started talking about Inter-VLAN Routing, how we can use legacy routing, having multiple lines up to something like a router, or we could do our trunking across a line to the router. We call that router on a stick, or we could use layer 3 switching. And probably the most prevalent out there would be layer 3 switching. So we then applied that to our network, layer 3 switching. And then we got into spanning tree protocol. Ideally, we would have multiple links across our network, redundancy across our network. But the problem is this creates loops, and loops can be devastating to our layer 2 network. And so somehow we need to eliminate those. Well, spanning tree protocol allows us to shut down those ports and only use the extra ports when needed. It does that through those bridge protocol data units. It sends these back and forth between these switches, thereby these switches now elect a root bridge, and then we'll elect root ports to get to that root bridge and then shut down those extra ports that are not needed. From there, then we got into link aggregation. We took a look how we could bundle these ports together so we can get more bandwidth between these switches, and how we could automatically set these things up with things like LACP, so we can auto-configure these. And what also is common on our networks is to have some sort of dynamic host configuration protocol, a way to configure IP addresses on our end devices. So we got into DHCP and Slack. We got into how we can set up the DHCP pool, lease time, reservations on these devices to be able to hand out IP addresses to end devices. We also configured the different flags on these devices so that way it could notify how these devices are supposed to get their IP version 6 address, whether through Slack, whether through Slack with DHCP version 6 or just DHCP version 6. Or perhaps our DHCP server is on another network and we need to forward DHCP requests onto a whole nother network. Well, we do that through a DHCP relay. So we talked about how to configure that on our devices as well. One of the common themes that keeps coming up here is redundancy. And we wanted to figure out how we could create redundancy within the different default gateways, to have multiple default gateways. And we can do that through HSRP. So we talked about how we could set up multiple gateways and use something like HSRP or FHRP to be able to set these as duplicates, a shared virtual IP address. And then one would be the primary that would answer to that IP address, but if it were to go down, then the other one would take over. Of course, all of these protocols introduce a certain amount of security vulnerabilities. So then we got into layer 2 security. We took a look at a note card for the different vulnerabilities that we have out there, what it is, how it works, different tools that will implement that, and also how to mitigate it. We explained things like MAC address flooding and how it can flood the network with MAC addresses. Therefore, this switch now becomes a hub and floods out all of the packets or frames that come into it, out all interfaces. So we set up things like port security that limits how many MAC addresses can happen on an interface. And then we moved into wireless LANs. We did a quick review over wireless LAN, things like the different channels and how we need to make sure that they're not overlapping too much. We also took a look at access points and how they act as a hub. And really, mainly this was about the wireless LAN controller, where we went over the different configurations of a wireless LAN controller and how a lightweight access point will communicate with that wireless LAN controller. So there's quite a bit of information that we went over, but congrats, you made it to the end. So congratulations for finishing the course and getting to this point.